Okay, this lesson is all about functions. Functions sound really scary, but they're actually not that bad. So let's look first at definitions. Y is a function of x when each x value corresponds with exactly one y value. In other words, this is what I like to tell kiddos, x cannot repeat. Can't have more than one x value. I'm going to look at this in different relations. A set of x values, x and y values, represented as ordered pairs. I might see it in a table. I might see it on a graph. Or I might see it as a mapping. The domain is all the set of x values, whereas the range is the set of y values. Now let's look at some examples. So first one I'm going to look at here are my ordered pairs. What I like to do is kind of draw arrows to all of my x values. Next thing I'm going to do is look and see, do any of those repeat? Let's see, I've got 2, 3, 4, and 5. Nothing repeats. So is it a function? Yes, it is, because x doesn't repeat. Let's look at our next example of ordered pairs. I'm going to look at all of my x values. See, I've got 2, another 2, 4, and 5. So is this a function? No, because these two x values repeat. Why? Because 2 repeats, which is an x value. All right, let's look at a table. So I'm going to look at a table similarly to what I looked at with my ordered pairs. I'm going to look at all my x values. Did any of those values repeat? 2, 3, 4, 5. None of them repeated, so yes, it's a function because x didn't repeat. All right, let's look at a graph. This one's kind of fun. Basically, what I'm going to do on a graph is I'm going to do what's called a vertical line test. I'm going to drag something vertically across my graph, and as long as it only touches that line or that curve or that arc or whatever it happens to be in one place at a time, that tells me that the x values did not repeat. So I'm going to take a pencil here and just kind of drag it across. The pencil's going to touch. I can see it touches right here and right here. But as I keep dragging it across, it doesn't touch in more than one place. So this one, yes, is a function because x doesn't repeat. So an example of one that would not be a function would be something like this. If I had a graph, let's say like that, and I had this weird squiggly line going through, this is not going to pass my vertical line test because if I drag my pencil across, I can see it touches here, 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 and here. It actually touches in 4 different places. So this one right here is not a function. All right, this is what's called a map. This is mapping. So it looks very similar to a table, but I have to kind of follow my arrows here. These are my x values. These are my y values, just like I would have in a table. So I'm going to look and see with my ordered pairs. This one says -3, 0, -1, 4, 2, 7, 4, 4. Did any of these x values go with more than one y value over here? No. So is this a function? Yes, it is, because x didn't repeat. So an example of mapping where it would not be a function, I might have -3, -1, 2, 0, 1, 2, and it might look like this. Again, my x and my y. So 3 goes with 0, 3 goes with 1, -1 goes with 0, 2 goes with 2. This one is not a function. And the reason it's not a function is because 3, this -3, it goes with 0 and it goes with 1. This x, see how I see two lines coming off of it? X repeated right there. So another way to think about it, I have -3, 0. I'm just going to write my ordered pairs. -3, 1, -1, 0, and 2, 2. The -3s I can see here, there's two of them. It repeats. Now, some kiddos get confused because two of the x values were going to the y. That's okay, because when I'm looking here, the y's, it doesn't matter if the y's are repeating. It only matters if the x's are repeating. These set of threes right here, those -3s, are what makes this not a function because x repeats. I can't have it where x repeats. Okay, so that's all about functions.